Okay, hello. Thank you for being here. Thank you for attending my talk. Oh, okay. Thank you for attending my talk, especially that in room 1 there's like a good selection of speakers on stage. So special thanks to you that you're here. What we're going to talk about today is HoloLens and mixed reality and how to kick off some development on that. So let me first introduce myself. I'm Rafał Legiędź. You can find me on Twitter at Traffic. And I'm a software engineer from Poland. I work for a consultancy company called SolidBrain. It's in Krakow. And mainly for the last several months, I'm involved in creating those AR experiences that you can run on HoloLens. I'm talking with different businesses, helping them out, creating proof of concepts, and get them understand what we can do with this kind of technology. Also, I'm a conference organizer. I organize a DevConf conference in Krakow, Poland for the last 8 years. And I try to be a conference speaker. So whenever I think I have something interesting to say, I apply to conferences, and hence I'm here, for example. So let's first explain the abbreviations that might appear in my talk. So VR and AR. VR stands for virtual reality, and this is basically the experience that you can get with a VR headset that you put on your head, and then you're being brought into the fully synthetic environment. Like your view is totally occluded, and everything what you see is rendered by the device. I mean, the computer or the device itself. And your mind is being tricked into thinking that the real world actually doesn't exist, that your world is actually this virtual world that you're in. And if you ever tried Oculus, HTC Vive, or anything like that, you probably know that it's really, really, really immersive. And also you can see lots of videos on YouTube with people freaking out in those headsets, right? So that we can see that the immersion effect is really good, and it's fully synthetic environment. On the other hand, we have AR, which stands for augmented reality. And this is something usually being run on mobile devices. And this is overlaying digital content over the view of the physical world over some device's screen. So whatever the device sees through the lenses is being displayed on the screen, and then some digital content is being overlaid onto that. And sometimes it's in the form of some wearable goggles or glasses. So, but we have mixed reality in the title, so it's not augmented reality nor virtual reality apparently. And Microsoft is using this term a lot recently, especially last year. So what is mixed reality? And I'm going to explain that because I can see lots of confusion about that, mixed reality. So we have those two words, like the physical one and the digital one. And it occurred that in between, there's a whole spectrum of experiences that we can get depending on the application or device that we're using. So all the AR experiences are really close to that physical reality end of spectrum, because still the physical world is really centric to the user when using most of AR devices nowadays, because they run on the phone, so the user is still fully aware of the environment around him or her, and well, the immersion level isn't that good. Some of them devices are a little bit more sophisticated. They have some more sensors. There might be in form of some goggles, so they can deliver a little bit better experience. On the other hand, we have VR, because, well, it's on this digital reality, and because, as I mentioned, it's whenever we are using VR, we are fully in this digital world. There's nothing coming from the external real world, actually. And even like when we are kind of immune to impulses coming from the real world when really being immersed into the virtual one. So that's why most of them VR experiences lay on this side. And HoloLens, the device we're talking about, this device, is actually an AR device. I mean, Microsoft likes to say it's a mixed reality device, but it's, in my opinion, it's an AR device. It lays on this side of the spectrum where physical reality is, because the user still is in this physical reality, but the way HoloLens works, how it can blend digital content into the user's environment, and that's it's in the form of glasses, it somehow delivers a more sophisticated AR experience that the user can be actually tricked into thinking that some digital stuff is actually the real one, etc. And the digital stuff interacts with physical things and vice versa. And some digital objects can be occluded by physical objects. So the immersion level in this case is really, really better than whatever we have seen earlier in our AR devices. And it's also worth to mention what was released in mid-October last year. Those were mixed reality headsets. And those are basically VR devices that are coming from Microsoft and partnering companies like Asus, Acer, Samsung, Lenovo, and Dell, and I don't remember what else. And basically, those are VR devices. But the main difference between Oculus Vive, for example, and those devices is that in those devices, there has been a technology from HoloLens used. So there is no longer need for external trackers to track the head movement and controller's movement. So we're kind of not constrained into the square being tracked by those external trackers, but the headset kind of tracks itself by itself. So it's a little bit more, those are a little bit more sophisticated VR devices. And this whole spectrum, that's what mixed reality is. So whatever is in that spectrum, that's mixed reality. So every experience here is mixed reality. It's nothing new. So AR is mixed reality, actually. So I think at least I cleared the confusion in some of us, because I was confused for a long time as well. So HoloLenses. This is the device. I have it with myself, so whoever would like to try it after the talk, I'm happy to show it. Who has tried it already? Yeah, that's what I think. Who have heard about it earlier? Yeah, that's what I thought, because I mean it's nothing new. It has been announced in it was announced in late 2015, then released in mid-2016. So it's been a while since it's on the market. And actually, there are lots of companies embracing this kind of technology. And they're actually selling this to other businesses. And I have seen like real products being deployed in factories and stuff. So it's a real thing. And it's happening. And, well, it's an independent computer, I would say. It's self-contained. It doesn't need any connection to any other computer, so we can go free. It's in form of the goggles, so we put it on our head and use gestures to operate. It also, it also runs Windows 10, so we can expect that the tooling to create applications for it is pretty common, I would say, and we will get to that later. And, well, you put it on your head, fire it up, fire the application on it, and all of a sudden you have some holograms in front of you and you can interact with, you can manipulate them, and, well, that depends on an application, of course. But it looks something like this, like you're wearing a headset and then you see this augmented reality thing. So how is that possible that we can get this kind of experiment, where we can expect that there is lots of fine engineering inside, and it is. Well, when it comes to sensors, you can simplify it by saying that there is a Kinect connected to your forehead, but it has something more. Those 4 cameras here on the sides, those are environmental understanding cameras. So basically, they're scanning user environment like all the time. Whenever the device is on, it scans the environment and reads remembers whenever the surface is, it just passes it forward to the system, just saves it in the system. And we have Rgb camera, depth sensor, mixed reality capture module, which allows us to record whatever the user using HoloLens see or stream it somewhere. I will show that later. Also, we have 4 microphones here, which are pointed kind of down towards user's mouth to be able to catch voice commands and to be sure that the voice command comes from the user's mouth, actually, not the person standing next to the user. And next things are optics. So it wouldn't be possible to display those graphics that would appear, like some of them would appear like closer to us, some would appear in a further distance from us. It wouldn't be appear without some advanced optics mounted there. So I'm not going to dare into details what kind of technology is being used there. Well, there's one disadvantage of this, is that the technology being used here doesn't allow for large fields of view. So it's not like we can see the holograms being rendered like everywhere, but we are constrained to like this kind of rectangle in front of us, so that all the digital content is being rendered here, and that's it. So that's why we can see like a lot of head movement when we are looking at people using HoloLenses. But apart of that, it's quite awesome. It has 2 HD engines, so it's basically 720p per eye, and it's enough. But we do not describe those screens in terms of resolution we might know from regular screens, because, well, we do not have to render like all the pixels because they're for free, like rendered by the real world. We do have to only render holograms, those 3D objects, and we are only caring about those pixels or points. They're calling them light points that builds up holograms. So that's the difference. And also we have holographic processing unit, which is a specially designed custom processor. It's a coprocessor for HoloLens that is responsible for processing all the sensory data that is coming to HoloLenses. So reading the environment or processing user gestures, etc. It all goes through this and then being passed for further processing. And a part of that, there's also like a regular processor, but it's 32-bit, not 64, so that might be a surprise for some. Also, it has Bluetooth, Wi-Fi, batteries that allow for like 2 or 3 hours of active use. And, well, that would be pretty much it when it comes to the most things when it comes to hardware. And how do we interact with this piece of hardware? How do we interact with holograms, and how do we issue commands? So we have the paradigm which is called WGV, which stands for gaze, gestures, and voice. So gaze is basically, you can describe it as a laser coming from your forehead, and that's the primary kind of pointing mechanism there. So whenever we would like to interact with some object inside application, we have to kind of look at it. And then if we are pointing at this object, we can then issue some command to that object. And usually it's visualized by a cursor that is being rendered at the end of this ray coming from our forehead. And whenever that ray hits an object or some other thing, the cursor is being rendered at that point. We'll see that in the example. And then gestures, we have 2 gestures there. Basically, the one is the bloom gesture, which is like that. This is the system gesture. And this is for closing applications or firing up start menu. And we can't use it in our applications. This is system gesture. We can't override it. But we have the other gesture, which is air tap, which is basically like this. This is basically a click. So whenever we are looking at something, this is the focus object then we can issue a command like that and then handle this click on this object. And we will see that in an example. But based on that gesture, there are some more gestures derived. So there's a hold gesture, which is basically the air tap, but we're holding the fingers together. And then there's manipulation and navigation gestures, which are like hold and then moving hand around. And then we can read the delta of our fingers being moved in the 3D space so that we can do some manipulation on our objects. And we will see that in examples later too. And also we have voice, where basically we can program voice commands, we can detect English words only, and it's just a mechanism for issuing commands as well. So basically we can look at something and say something, and then something will happen. Or just handle some commands like globally without focusing on some object. So that's pretty much it when it comes to interaction. So given that this technology, we have all sorts of different scenarios that we can solve with this device and technology. So just to name a few, and really if you look in the internet, there are plenty of them. I mean, you can see companies growing on this technology. And I'm gonna just show you just a few of them. which are pretty famous. The one is from a city company. You can see basically like a trading or financial app here where all the data is being rendered in form of some 3D objects, and this person can just interact with those data using gestures and gaze. And some other person sitting somewhere else can also see that because you can share this environment. And well, for all of those examples, you can Google them and you will see videos on YouTube on how they work, actually. And the other example is Ford. They announced recently that they're using HoloLens for design purposes and to enhance their design process. And what we can see here, for example, there are two people wearing HoloLenses. And this is one of the cool features of HoloLens where you can basically share the environment, the holographic environment. So those two, if you write the app where those two apps can talk to each other, like shared session, then the coordinate system of those two applications like align, and then both users see kind of the same set of holograms and they can interact with them together. So that unlocks pretty cool collaborative scenarios, I would say. And you can add up like several HoloLens. I don't know what's the threshold. I mean, probably 20-something or something. I mean, in terms of performance. And then we have Schneider Electric, which is, they created an app for service workers. So there's a guy walking towards some kind of appliance or piece of machinery, and then you can detect if this is this kind of machinery that we are supporting, and then overlay some digital content onto that machine, showing some steps or some instructions or whatever we might think is suitable. But if you would look at this video, basically it's a maintenance app. And it shows like arrows, like unscrew this bolt or whatever. I mean, you can just render anything. And ThyssenKrupp company from Sweden, they're manufacturing. They manufacture elevators. They also have an application for maintenance workers. So whenever someone wants to do some work on some elevator, he can get or she can get some contextual information about this particular machine that the work is being done on, and we can have like a model being displayed of the piece that we're going to do some work on, or some manuals, video tutorials, like whatever we want, right? Based on the thing we're working on. But those scenarios, they do not use one of the coolest features of HoloLens, which is spatial mapping. As I already mentioned before, when I was describing the sensors, we have 4 environmental understanding cameras there. And there, from the moment the HoloLens is turned on, it constantly scans the user environment. I mean, you can't stop it. You can turn off HoloLens and then it stops. But whenever it's turned on and even laying like that, it just scans everything it can see, like up to like 3 meters or something like that. And it stores it on the operational system level, on hard drive, and it builds like internal models of locations it detects it is at. So we can't access it directly. I mean, we can't go anywhere in the system and just see what kind of locations are saved. But as developers and creators of the apps, we can have access from our application to this data. So basically, in our application, we are getting, if we're using spatial data, we are getting a full 3D model of our location. So basically, we can have like the mesh of the room we are in, right? And that mesh is aligned with all the surfaces. So we have floor and walls and some chairs, etc. So we have this mesh. And in this case, this mesh is just visualized. It has some material applied so that you can see it actually, because well, everything what is black is actually transparent on HoloLenses. So if I would run it on HoloLens, I would see like this white grid like laid over on every surface here. But what's exciting here is, along with this mesh, we are getting also the colliders. Colliders is a kind of mechanism in the engine that allows us to program interactions between digital objects. So if we program some holograms, some 3D objects in our application, and have colliders everywhere where we have surfaces in our real world, then we can program some interactions between our, for example, our digital ball and our physical floor, because that ball will hit the collider that we can't see, but it is aligned with the floor. And then you have all those scenarios where you can actually interact with physical objects, right? So we have, for example, those are games released at the beginning, when HoloLens was released, to show the possibilities of spatial mapping, let's say. So, for example, we have games where agents are walking on your floor or jumping on your table, and it looks fantastic. It's really convincing. And this game, for example, this is Fragments, my favorite. Basically, your room is being transformed into a crime scene, and you are a detective, and you actually have to look for clues that are hidden somewhere in your room. So you have to actually crawl on your floor and just peek here and there and just look for clues, which is awesome. And you have some hologram people walking around, and they can actually sit on your table or sofa, which is super convincing as well. Because when they were programming this application, they can detect where are the seatable platforms, and then they can program this agent to just find seatable platform and just sit there. It's super awesome. I mean, this experience is pretty awesome. And the other thing, Roborite, I think this is the most common one. It's an alien invasion that the aliens are drilling through the walls, and they start shooting at you, and you can shoot them as well. I mean, this is really cool. I mean, you should try it if you haven't. So tooling, right? We are here for a session about developing. So this is the goal. The previous slides was the intro. And here we're going to the core thing. So the most common tools for developing apps for HoloLens are Unity and C#. Well, and we can write this C# in MonoDevelop or Visual Studio. And this is not the only scenario, I would say. You can use DirectX and C++, Unreal Engine, or C# with SharpDX or UX. I don't remember the name, but whatever. I mean, there are several options, but the most common one and the best supported one is this one. I mean, it's supported by Microsoft, by Unity, and the community that grew around this technology also uses mainly this setup. So, and it's really nice to use, I would say, because writing C# scripts and using Unity, which is pretty nice IDE, gives us, well, I mean, we can quickly create some proof of concepts, for example. I will show you that in a second. Also, although Unity got support for HoloLenses not that long ago, and we can use scripting API from Unity to write our apps, there were people in Microsoft and other companies that were creating the first demos that were using that, and they observed some patterns, some commonly used scenarios, etc., etc., so that they extracted everything that they thought might be useful, and then they created this package which is called Mixed Reality Toolkit. You might have heard about it, but earlier it was called HoloToolkit, and this is an open source library with a set of components, scripts, and some shaders, materials, etc., that really speeds up the development, especially at the very beginning. I will show you that later, and my demo is going to be based on this one, just to show you how quickly we can get into some app into just for the proof of concept thing. And also we have Mixed Reality Design Labs, which is also an open source project, but this is more like demos on how things can be done properly, so that we can just read through the code and learn upon it. I'm gonna show you, well, this is the last slide, demo. And now let's jump into, I'm going to show you quickly, this is the, oops. So, okay. Can you see that? So this is Mixed Reality Toolkit. And, well, it's on GitHub. It's all well documented, I would say. We have everything grouped into categories so that whenever we want something to handle like input, like gestures or voice, it's here. For sharing, it's here. Special mapping, etc., 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 etc. It's a very well maintained project, I would say, especially that it is very fresh, I would say. So, well, and if we go to input, for example, I don't know if internet should have. Yeah, and we have all the things we need, including diagrams. Whoops. But what I want to show, I don't know if to make it bigger. Okay. What I want to show is that if we would like to, for example, program some gestures directly in Unity, we would have to write some code, like significant amount of code. But using Mixed Reality Toolkit, it all boils down to implement some interfaces. So basically, if we want to handle air tap on an object, we just implement input click handler interface and just implement one method there, which makes it way more easier than just going through the Unity scripting API. And I strongly recommend using that, at least at the beginning. And the other thing, design labs, as I said, this is the set of like ready things that we can go through and see the code and how the things are done, how materials are done, how shaders are done, how interactions are done. And this is also done by Microsoft. This is kind of a point of, could be as a point of reference to see how things could be done. Okay, and I think now it's the demo time. I have still, how many time? 24 minutes, something like that. Okay, so this is Unity. How many of you have already seen that? Okay, so quite a lot. So what I want to show you is how to create like really simple proof of concepts, because like, I mean, based on my experience, most of the people, businesses that ask me to do something for HoloLens is basically to visualize some model that they have and to put it on HoloLens and just render it and just do some simple interaction with it. That's usually the first step. And well, I wanted to show you just that, how to put some hologram into HoloLens and just do some rotation on it, as simple as that, and use spatial mapping so that we will be able to actually put it on our floor. So yeah, this is okay. So this is Unity. This is the IDE of Unity, and well, to just go quickly through the components. This is the main scene view. That's the place where we lay out the whole scene of our application. I mean, all the objects, cameras, lights, and all that stuff, music, audio, I mean. This is the hierarchy pane, where we have all our objects that are being used in the scene right now. This is a project pane, where we have all the assets imported so that we can use them in the program. And here's the inspector pane, which is basically like the displaying properties of the things that are highlighted in the hierarchy. Like when I highlight this object, then I get the properties of this object and can act upon it. Let me get my cheat sheet. Okay, so yeah, so I have a model of a forklift, and I would like to place it somewhere on the floor here. And well, sometimes, I mean, most common scenario is that the customer sends me a model from SolidBrain or AutoCAD. And the first step here would be to convert that model from solid to mesh. And that's something that I'm not going to go here into details, because that's a pretty complicated thing, I would say. And there are tools out there to do that. And well, let's start then. I've started this empty environment and already imported HoloToolkit or Mixed Reality Toolkit. As I mentioned, I did that before because that takes time to import it, so I wanted to have it in place. So as we can see, I don't know how to. Okay, I want to magnify. Okay, so here is the HoloToolkit. Can you see that? Pretty clear? Okay, and as we can see, as you've seen already on the GitHub, in the GitHub repository, there were like categories there, and everything here is more or less in the same, I mean, folders here are more or less the same as categories. So if you want to look for some components for input, like gestures, for example, or camera, we look in input folder and then just go to prefabs, and we have everything we need here, right? Okay, so first things first, we need to delete the camera that is being put here by default, because this is not, it's not configured for HoloLens use. It's just configured for regular games that runs on a computer or regular screen. So we need to delete that one, and I'm gonna drag some components from Mixed Reality Toolkit, like HoloLens camera, which is camera configured for HoloLens, and then Input Manager. This is something that is being responsible for our gestures, for example, and voice commands. Also gaze, like the pointing mechanism. And also I need a cursor. What I want to show you here is that, What I want to show you here is that it's super easy to kick off. I mean, what I'm going to show you is that I'm not actually going to write that much code, because that's kind of easy with this toolkit I'm using. And also, we need special mapping because we need access to our floor. So I'm going to get the special mapping. I'm going to zoom in a second to see, for you to see what kind of components I imported. Whoops. See, camera, input manager, cursor, and special mappings. And so those are the components I'm using. And the naming is pretty straightforward, I guess. So, okay, I think I could run it, but I could run it, well, the usual question is there an emulator? Do I have to have HoloLens to run the application, to test it, etc.? So the answer is you do not have to have HoloLens. I mean, obviously, you have to have it to like properly test it, but for the a regular workflow and just creating some common stuff, or just proof of concepts, you basically don't need the device. And there are two ways you can test it. One is you can run it in the Unity editor directly, which is possible from some time, and also you can build it, and after the build, this Visual Studio solution would be created, and then you can run it in the HoloLens emulator in Visual Studio. But this is I would say, it's not, this emulator is quite heavy, so I don't have enough patience, for example, to use it. So I do recommend using it in Unity, because you don't have to switch between environments and just do builds in here and there, and because that just breaks the workflow. So what I want to show you is how to run it inside Unity. But the disadvantage is that when we are in Unity, we do not have the model of our room, for example, right? And we would like to test spatial mapping. So how to get the room into Unity? So we can do it in two ways. First would be we can fire up for once this emulator I mentioned, and we can get a room model from there, because Microsoft delivers like 5 models there of some rooms, which are basically the 3D models, like regular models. Those are basically meshes, which just looks like room. And we can get some from there, or we can fire up our HoloLenses, which I will show you how to do it, and just scan some room and just grab that model, export that model, and just import it in Unity. I do have one model prepared, so I will just import it as an asset. This is a regular 3D object, nothing fancy, but it allows us to simulate that room inside Unity. And what I have to do is basically select the special mapping component and just drag that room into the special place in there, which is room model. And this is this works only for Unity editor. It won't go anywhere to our HoloLens app that would be deployed on HoloLens. So it's only for testing purposes here. And basically, we can hit run, and bam, we have a room model, and we can, using WASD and the mouse, we can basically walk inside that room. I don't know if you, well, you can see it's a room, right? Somehow, right? It looks like a room. It looks, and we can see the cursor, the blue thing that hits the, whoops, where is it? That hits the surface, and it sticks to that, so that we have this this point where we are where our gaze is pointing. We have this point visualized, so this is very helpful. So yeah, that's this. So with some simple drag and drop, I created an app where I have cursor, I have a gaze, and I have spatial mapping, right? So next steps are some setup for Unity environments, so that we get to we need to set up Unity environment so that it knows that we are doing HoloLens development. So if we're having mixed reality toolkit, it's as simple as just getting here mixed reality toolkit option in the menu and just apply mixed reality project settings. So basically, we need to tell the environment that we are targeting Windows Universal UWP application. We're enabling mixed reality, direct 3D, and .NET backend, scripting backend, because we're going to write scripts in C#. Okay, hopefully it worked. And also, as we are using spatial mapping, and we will be deploying that to HoloLens, we need to ask the device for the user for the device for the permission that we are going to use spatial data. So that's the same as permission in mobile apps. We need to ask for that. So that's here. We need spatial perception capability setting. And then we're done with the setup. So right now we need that forklift. And I have this asset prepared, so I'm going to import it. Yep. So what we would like to do is to be able to look at the floor and air tapping, and then the forklift should just appear on that floor at that point, right? Let's just check if that forklift actually works and renders. There you go. Here is our forklift. And we can just run it. Oops. And here's our forklift, like hanging on the ceiling. And that's because I put it in the 0, 0, 0 coordinate. And 0, 0, 0 coordinate, it's where our head is when the application runs, right? So that's why it's hanging from the ceiling. But we want to delete this, and we will write some global script, which means it won't be attached to any particular object in our scene. So we just need to create some empty object, because we can't have scripts in Unity which are just somewhere. We have to attach them to some object. But in this case, we need some object to just hold the script, not a physical object that will be rendered. So I'm just creating some empty object, which I'm just going to name program. And as you can see, I've added this. And to add a script to that, we are going to inspector and just, whoops, get out of here. And I'm just clicking add component, and here I'm going to type program and that's going to be my script. There we go. And double click on this. Come on. There we go. And Visual Studio will pop out. And here is where I will be writing my scripts. And you will see that I will basically write something like 5 or maybe 7 lines. Okay, let me zoom in a bit. Can you see it? Okay, so this is how scripts look like in Unity. They all inherit from mono behavior, and they have several entry points that you can program in those methods. And some of them are, two of them, the most important ones are start and update. And there are some more of them, like enable, awake, fixed update, late update. But I'm not going to go here into detail because that's not that necessary right now. But start method is being run when the application starts. So start method is being invoked on every object that is on the scene at the moment of application start. Then update method is something that is being run like 60 times per second. It's the same time, as often as the frame rate is. So this is where all the animations are happening, right? If you are rotating something like continuously, it will be happening in update method. But what we want to do is we want to handle here the air tap and check if we are looking at the floor, right? If we are looking at the wall, we don't want the forklift to appear there. We want it to appear on the floor. So I want to implement air tapping. So I'm just gonna click handler. I'm gonna implement input click handler interface that comes from this mixed reality toolkit. As simple as that. I'm gonna implement that, and I have only one method to implement here, which is on input clicked, and that's where all the magic will happen. That's it. And to handle that, because by default, the gesture would be handled on the object that we are looking at. This will be the focused object. But here we're not going to look at anything particular. Well, we're going to look at the mesh, the spatial mesh, but we're not going to attach any script to that mesh because it's not the way how we do it. But we want to handle that gesture kind of globally, so that if we do not have any object focused, just fall back to this script and handle air tap here. So for that to happen, I just need to push fallback input handler, which would be this script. Game object is the reference to this object, and all the air taps that are going to be fallbacked will go to this handler. So if we will be looking at anything like our floor and do a gesture, air tap gesture, it will fall back to this method and invoke on input click method. So on input click, we should get the point where we're looking at, right? Because we want some details of that point. Focus details. And we're going to use Focus Manager, which is from Mixed Reality Toolkit. And this is something funny. I come from, I used to do a lot of like enterprise stuff with C#, etc. So you haven't seen a lot of singletons or public fields and all the stuff. And all of a sudden in C# scripts in Unity, you see all of them. You see lots of singletons, and you use like public fields, and it's all normal. So yeah, I got used to that. So we're gonna get focus details here based on our gaze. You see, I write instance everywhere because those are all singletons. That's crazy. Yeah, so what I will get here, focus details will be, those will be details about this point that I'm looking at. So I'm going to get normal vector there, I'm going to get coordinate of this point and some other things. But what I'm mostly interested in here right now is if it's a floor. So I'm going to do just simple calculation here. Basically, I'm going to check the normal of this point and how much it diverges from like the up vector. And if it's going to be like some, I don't know, I will set some threshold. If it's going to be like 15 degrees or less, then I will assume it's a floor. I mean, as simple as that. Float angle from up. Yeah, in Unity, you're doing a lot of vectors things. That's kind of something you have to get used to it. And well, I'm just invoking the method that will get two vectors and will calculate the angle between the vectors. So I'm just gonna do this. Vector 3 up means the vector up. As simple as that. And I'm gonna get the normal of the point I'm looking at, so that I have this normal vector from there. And when I calculate it, and this angle from up will be less than 15 degrees, then I'm assuming it's a floor, right? As simple as that in this case. And well, I didn't mention that earlier, but there is, in Mixed Reality Toolkit, there's a component called Spatial Understanding, and this component delivers us some cool features about on processing spatial meshes, so that we can really detect, I mean, there are really components for like detecting floors, ceilings, and places, like empty places on walls where we can place stuff. So I highly recommend using that. But for the like demo purposes, I just use this just to show how to write simple scripts. So if we know we are looking at the floor, we need that forklift model. So obviously, I'm going to do a public field here. Forklift prefab. And I'm going to, prefab is something that sits in my assets folder, and this is an object that is not in the scene, but I'm able to instantiate it, right, and put it in my scene. So I'm going to do it right now. So I'm going to instantiate my prefab as simple as that, right, and then I'm going to place it. This is my instance of my object, and just going to change the transform of it, its position to my focus details point. So basically, I'm getting the point where I'm looking at, like the coordinates of that point, and setting to that forklift transform, right? The position, as simple as that. And after that, I would like to disable that ugly mesh I'm having everywhere on my spatial data, so that it will. So that I won't have that white mesh, so I will think that this forklift actually sits on like real floor, right? So special mapping manager, of course, instance, draw visual mesh as false, bam. And well, I still need that prefab here, right? I have to do this dependency injection thing. So in Unity, dependency injection looks like this. Wait a sec for it to refresh. I don't know if you can see that, but here, the new field appeared on my script. Those are the public fields I have on my scripts. And this is the forklift prefab here. So I'm doing my dependency injection like this. I'm checking that script and just doing this. And that's it. I just passed the reference. This is the, I don't know, the drag dependency injection or something like that. I don't know. But well, we can run it. And cross your fingers. Gonna click here and bam, we have that forklift, right? At this point. And our mesh disappeared, right? So that when we will run this on HoloLens, everything that's black will be transparent, and we will have the forklift sitting on our floor. So let's just add one more thing here. Basically, we would like to grab that forklift and just rotate it, as simple as that. So that's gonna, we're gonna select our prefab here, and I will attach a script to that and just implement rotation on dragging, and that's it. So I'm clicking Add Component as I did before, but this time on this object, and forklift behavior, bam. Yeah. Now you're familiar with this. But right now, I don't want to air tap on this model. I need to do manipulation on it. So I'm going to implement manipulation handler interface. And it has 4 methods to implement. One is on manipulation canceled, completed, started. I don't want to implement any of those because I don't care right now about this. What I need is manipulation updated. So that I need the point where I can get the delta of my hand movement and then use it to rotate the object, as simple as that. So for this to happen, I need to implement onManipulation updated method and get the delta somehow. And it sits in even data that is being passed here and cumulative delta. So I need to rotate that object. This script is attached to that object. So in transform field, I have the transform, the position of this object. So I need to invoke a method which is called rotate. What a surprise. And I need to pass some values here. So basically what I have to pass here is the vector, like x, y, z, and depending on which values where it will rotate on a particular axis. So first value is, we want to rotate it like this, like along the y-axis, and we need to use this gesture. So this is the x value of delta, right? So we're going to just pass 0 for like x rotation and pass here delta x, right? X value of my manipulation. And for z, we're going to pass 0. Okay, so 2 lines of code. Let me place it. Come on. Oops. There we go. Okay, I'm moving. Okay, I'm probably missing the minus there, but you see, it's rotating. And well, as you've seen, I haven't written like lots of code. It's really simple, and this is like the most common scenario for me. I mean, most of the time I just do this kind of things. I mean, I spend most of the time converting objects from SolidWorks to meshes than to actual program it. But yeah, as simple as that. Sometimes I do something more, like I program animations in Unity so that you can click through the object and it will just tear into pieces and stuff, and so that it gives a little bit more insight. So I still have some few minutes, so I'm not going to deploy it right now because that would take too much time, but basically the workflow looks like this. We have to build it here in Unity. We're adding the scene, the open scene that we want to export. We have everything set up because I've clicked through the menus before, and basically we build here. And what happens after we build here is the Visual Studio solution is being created. And then we go to Visual Studio, open that, and then we can deploy it to HoloLens. And we can deploy it in several ways. We can do it via USB cable. We can do it remotely via Wi-Fi. Or we can build a package and just load it through the device portal, which I will show you in a second. So I'm not going to do this. I'm just going to try to show you this thing. Okay. Okay, so it should work. Wait a sec. Okay. Okay, so first let me show you this device portal. So basically when you connect to your HoloLens by entering your HoloLens's IP address to the browser, you will get the device portal of the device. And here you have some pretty cool options, and I will show you some few of them. I mean, the rest is like diagnostics or uploading apps or deleting apps or some kind of maintenance stuff. But I'm going to show you this, for example, so that you can see that it tracks my movement, right? And if I would click update here, it will show what it already knows about this room, right? That's the model it's building inside, right? You see? So this is what HoloLens knows. And from this place, we can export that model, actually, and import that in Unity, as I've shown you, right? So for example, I was, because I work remotely, I travel to the office like once a month, and I wanted the model of the office, which is in Krakow, but I wanted to have it at home. So I basically was going through the office with HoloLens and then exported the model, and that's it. I had the model. So yeah, that's a very helpful thing. And the next thing is this mixed reality capture thing I already mentioned at the beginning. That's where we can do the streaming. The thing is that we have a big lag here. You see? And this is, I don't know why. I mean, it's how it works for everyone. So, but it's still, we are able to show someone how things work. So let me fire the application. I deployed it earlier so that we won't take too much time. Okay, I already see that. I need to look around to grab some more data, because I mean the HoloLens constantly scans the environment, so it updates the mesh all the time. And if I'm displaying this mesh, it changes as quickly as the HoloLens have more information about the space. So when I already have my floor, I can just air tap there, and just look at my beautiful forklift. Yep. Well, that's pretty much it, as simple as that. Any questions? That's all I wanted to show you. I'm happy to answer any questions or give you the whole HoloLens to play with.
Yeah, can you buy these things?
Of course you can. Pardon?
Used by the Connect, right? And it's using similar technology to Microsoft Connect.
Yeah, it's very similar. Yeah, I mean it's more advanced, but yeah. And you can buy those. Yeah, of course. I mean you can just go to Microsoft.com and just buy them. There are only 3,000 euros. So for a dev kit, which has no warranty. So the enterprise version, like the real one, the consumer one, is 5,000 euros. So it's, well, but it's targeted to businesses. It's not the consumer market.
Not targeted to, like, yeah, your kids playing games. No. I mean, it's not the target. It's too expensive. You have some games there, but those games are basically created by developers who just want to show up, and that's it. You can't expect basically to earn money from the store for HoloLens. No, you can't expect that. There are more than 300 apps, but as I said, it's mainly just show off by developers just to see that something's going on. But no, I mean there are several devices out there on the market actually. I mean, Google Glass still is alive. There's Epson, there is Meta 2, etc., etc. And all of them right now are targeted to businesses. I mean, no one is doing consumer-targeted glasses. And that's what Google did in 2013 with Google Glasses first version, and it quickly occurred that the market isn't ready for that. So. What about Magic?
Well, Magic Leap is, well, it's still kind of a fairy tale or something like that. I mean, they're doing it since, I don't know, I don't remember, I mean, 8 years or something like that, and they're just getting money, and they recently released something, but it's still like renders, so I don't know. I mean, I'm keeping my fingers crossed for them because it looks really cool. But until we get something and get the community around it and all that stuff, I mean, HoloLens and Microsoft did a great job because it's on the market. It's expensive, sure, but the community is out there, the support is out there, and you can actually sell this stuff, and that's it, right?
I heard from my colleague that at the Tate Modern, they've got an exhibition. I think it's Modigliani, and they've got a model of Modigliani's studio, sculptor, and you put the thing on, and it's like you're in the studio, and you can see.
You mean HoloLens? Yeah, I mean, yeah, you can see them in many places. Yeah, not only factories, but yeah.
No, art gallery is not far from.
Yeah.
How does it deal with like outdoor places and far distances? Does it deal with
Well, it scans up to 3 meters from you. So, but if you want to scan something out there, you have to go there. That's the question. Yeah, it's like 3 meters, and it all depends on the lighting as well. If it's darker, it wouldn't scan that well. Yeah.
I mean, does it know that like something is like the sky as opposed to like a ceiling?
Well, I'm expecting you will have just nothing there. There wouldn't be mesh there outside. Yeah. I think you could post-process this mesh and just do some stuff afterwards, but yeah, by default it will just not detect it. I mean, the same thing is, for example, with mirrors. If you look at the mirror with this, it will just think there's another room there. It's tricked by the mirror. I mean, as simple as that, right? Yeah.
Right. So it's a visual. It's not a laser thing or a radar thing.
I don't know. I mean, it's
your eyes.
something like that. I mean, you can trick this device with the mirror. Yeah.
But it's stereo. So there's 4 cameras that can know the distance. By
Yeah, something like that. Yeah.
calculations, stereo
Yeah.
calculations.
It builds old model. Yeah.
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 How does it deal with like moving environments? Say if there's like a river or something.
Oh well, yeah. I mean, moving parts is not the best thing here. I mean, it constantly scans. So, and if for example I would fire it up here and you start leaving, it will just constantly update what it sees. So sometimes I will have your silhouette here, and then after a few seconds I will have you there, etc. So it just scans, and it's up to you if you would like to freeze your current state and then post-process it or not. So it depends on the scenario, actually.
So it wouldn't be good, like if you're throwing balls at the thing.
No,
and
it's
extract the balls.
no, it's not that. I mean, it probably could apply some algorithms based on what camera sees, but it's not like it's built in. There are things that you can apply some image processing, of course, and detect things, but it's like using some other stuff, like machine learning or whatever. Yeah.
Hi there. How does it cope with? I mean, can you sort of tell it in advance? You're in this room. Here's the model. Does it tally that up with what it sees? I mean, can you, for example, if you're in a factory where you couldn't scan the whole building, can you give it the model of the building and say, work out where I am in this space? I am definitely in this space. Does that?
Well, no, you have to have to at least visit it once.
No, but I mean, if you know the space, is there any idea of saying you're going to be operating in this space? Here's a model. Tally what you're seeing up with the model. You know, so you kind of. You can then, could you then know that there is a wall 20 meters away, for example?
If you have a model, then yeah.
And you can tally that up with what it's seeing.
Yeah, I mean, you can put something which is called spatial anchors here and there, and those are those special points that can be remembered, and you can do calculations based on that. So you can do something like that, yeah.
Okay.
Yeah.
Yeah, how does it match up? I mean, so say if you have, like you said...
No, I don't know. I have no idea. This is black magic for me. I have no idea how it detects that it is in this room. I mean, this is black magic. I don't know, because you fire it up, and it has, like, for example, this device probably has, like, tens of spaces remembered there, like separate spaces. And if it's turned off, if I would turn it on, it would somehow match. It will look at this space and will probably, with like 99% of sureness, it will match this room, it will detect that it is in this room. But how it does it, I have no idea. It's probably a combination of several things. I have no idea how. No, sometimes it is. Sometimes it's confused, and then it will ask you. It will pop up the window and will say, "I have no idea where are you. Just help me select the space that are you in, or let me create like a new one." But that's usually depending on. That usually happens when I have bad lighting. That's most usual case.
Are companies interested in developing HoloLens applications?
Cool.
In the last 6 to 12 months, the companies ask you to develop more applications for HoloLens.
Again, I don't think I understood the question.
Are they interested in developing?
Oh, yeah. I mean, well, it depends. I mean, I'm talking to many executive guys, and it depends. It depends on the mindset usually, because you have to kind of see the potential and things. And sometimes I'm talking with guys that, you know, they are doing like they're migrating from, for example, Excel to mobile applications inside their companies, and then I'm telling them about using AR. So for them, it's like, not now. But if you're talking to someone who has like a mind open and feels it, then you can talk about the future and how it can be employed, etc. So for example, I already delivered like several proof of concepts, and well, one company wants to talk more about this and how we can build up on it. And some of them are like, all right, we're done, etc. So it really, really depends. But there is an interest, that's for sure. Yeah.
So for you, just to repeat what you said, you've got lots of proofs of concept,
Yeah.
but you've not actually yet.
Well, you have to sell it to someone. It's new to everyone. It's new to developers.
Yeah.
So think about people like, you know, executives or managers, etc., who are not that close to the technology. So you have to actually build the awareness, what's possible. For them, like for the first sight, it's like, oh, nice toy. I would buy it for my kids, right?
Yeah.
But then you have to kind of, you know, explain them that it's not for kids. That's a real thing. It's not the future. It's like it's right now.
But I actually know two people who work for companies that are actually, one is maintenance, like similar to what you said. They probably saw the video, but it's for phone masts. They're actually developing it right now for real. And the other one, they've developed this thing at the tape. Yeah, they worked on that. I haven't seen it, but she told me.
Yeah, exactly. But it's happening. Yeah, the future is now. Any more questions? Thank you then.
Yeah,
Thank you very much. You want to try it?